Justin, are you sharing your screen or am I sharing first?
Justin there.
Yeah, sharing.
Jayesh, Justin, are you doing the introduction? Or shall I just start?
Yeah, you can go ahead.
Oh, okay. In that case, yeah, I'm going to share my screen, Justin. Sorry, let me take control. Do we have the delegates? Okay. Hello, all. Welcome to our webinar today. The topic is Data Lake House in the Age of AI. My name is Shri. I'm the founder, CTO of Alpharithm Technologies. Today we have with us Venkat Iyer, who is our chief architect, and Arvind Subramaniam, who is our Gen AI specialist. So today's topic is going to be around Data Lakehouse, as you can see. We are a data and AI specialist as a company, Alpharithm, and we've been around for about 10 to 12 years now, specializing in data and AI. As a business, we have three practices: ERP, data and AI, and ESG. So today we are focusing on the data and AI practice. And within that, we have a lot of solutions that we offer to customers in the data and AI space. We work with financial services companies, insurance companies, manufacturing, pharma, media, retail, pretty much vertical agnostic, in helping them look at the data, understand the landscape, and help them derive value from the data that they have. Now, these are some of the technologies that we work with. Most of you must be familiar with these data and AI technologies. These are market leaders, so to speak. So as you can see, there is a wide breadth of experience we bring to the table in terms of solving customers' data challenges. So today everyone talks about AI. AI is not new as such, as most of you would know. It's been around for a while, but there is a lot of focus around how do we bring AI from, let's say, a consumer-facing ChatGPT type of interface into the business. So we're going to sort of go through some of the use cases today, because most of the new initiatives that customers like you are working on today is around bringing these AI use cases into the business and how do we derive value from that. But you need a solid data foundation for AI to work, and which is why we thought that is very topical to talk about, setting up that foundational data platform that will allow us to give data, good quality, trusted, governed data for AI to work. So that's what we do as a company, and we work across a lot of different technologies that you see on the screen now. From an AI perspective, that will be OpenAI. In Amazon, you have Bedrock, and IBM, you've got watsonx. And these technologies are changing so rapidly. Our challenge as a service provider, as well, is to keep tab on what is going on in the market, and that's what we do. And on the data side, we work with large enterprises like Databricks, Snowflake, Starburst. These are all very dedicated data lakehouse type of companies, and also the traditional companies, which is IBM and Oracle and all that. And on the BI space, we work with some of the latest and greatest BI providers, and of course, a lot of stuff is also happening from a data integration perspective, and we are partners with IBM Informatica and open source providers like Apache Airflow. A lot of customer success stories that we have, especially around insurance, banking, and pharma, as you can see here, helping customers, bring all the data, ingest them into a central data warehouse. Used to be called data lake. Some of them have data lake. Today specifically, we're talking about lake house. So a lot of experience around putting governance in place so that customers who use this data can eventually trust the data that is being delivered. So today specifically, these are the points that we're going to cover. It's a broad agenda of what we are looking at. So we're going to quickly talk about market trends. What is that we are seeing in the market? Some of the challenges the customers are facing because the technology is changing every single day. How is it evolving, or how has it evolved in the past, from the past to where we are now and where we are getting to in the future. My colleague Venkat has also introduced us to a reference architecture from a Lakehouse perspective, and touch upon some comparison use cases, and also look at some of the key vendors in this space. Because as customers, you are sort of grappled with and confused really about which technology should I go with to solve some of my business challenges. So we can help you with that, and also look at some benefits that these lake houses will bring to you, and also look at some of the Gen AI use cases that you could apply once you have your data story ready. So in terms of market trends, right? Everybody is talking about AI. A few years ago, AI meant that you could build a predictive analytic model, such as predicting customer churn, next best action, and so on and so forth. So that is on one side. But today, with ChatGPT's introduction last year, people are thinking, how do I bring this ChatGPT generative AI sort of technology into my business? How do I live? I have a lot of data that I'm sitting on as a company, which has been accumulated for the past 10, 15 years. But I want some technology like ChatGPT that has to be brought inside the company where I can generate value. Now, every single CEO is talking about it. It's become a boardroom conversation. And 75% of the CEOs are saying that Gen AI is very important. It's a competitive advantage for growth of their business. However, they are grappled with a lot of different challenges to introduce AI into the organization. Because some of the customers we speak to, they say, my normal BI itself is not working. And when we say, why is it not working? They say, with the data sitting across multiple data silos, there's the volume of data has increased over the years. Different formats of data I have. Some of them are structured, some of them are unstructured. Even the structured data is sitting across multiple different flavors of the databases. And then the data quality itself is pretty bad. So this is a common theme that we are seeing across enterprises, right? Now, if you don't solve this underlying data infrastructure problem, we cannot get anything done in AI. Like the old adage goes, garbage in and is garbage out. So if we feed incorrect, bad quality data to your AI engine is going to give you incorrect results. We could call it hallucination. We could call it sometimes they say AI is lazy, and so on and so forth. You have to pass accurate information for AI to work. So today we are going to look at how do we make sure that we build a solid data foundation for AI to work and to derive actual value, tangible value from AI. So this is a theme that is resonating quite well with most of the customers, that there is no AI without IA. AI, everybody knows, IA is basically information architecture. That is building that solid data foundation for AI to work and for AI to predict the right results, perform your task, automated tasks. And also, we are also today talking about ethical AI, responsible AI, being able to track the outcome that AI produced back to the source system, and so on and so forth. For that, you need a good data infrastructure in place. So in terms of where we are, today, obviously the topic is Lakehouse, but this is not exactly a new concept. Most organizations have been doing some sort of data, running on some sort of data platforms. So in the early 90s, we were talking about data warehouse, right? So everybody went on to data warehouse because the challenge was the data was sitting across multiple silos. As long as we could bring all this data together into a central data warehouse and run some BI reports, great, job done. But then there were a lot of challenges in running a data warehouse. There was vendor lock-in, the scalability was limited, and so on and so forth. And it was only used for specific use cases. And then in early 2000s, right, we had data lake, concept of data lake with the advent of an Hadoop type of infrastructure. We had a concept of data lake because a lot of unstructured data started surfacing in the organizations, right? Images, videos, and so on and so forth. So customers needed a place where to bring all this unstructured data and run some analytics on top of it. So data lakes were great to bring all this data into some sort of Hadoop data store or an object store and run analytics on top of it. The problem with this was the structured data was suffering. So you still had to maintain a data warehouse, and then you had to maintain a data lake. And then came cloud data warehouse. So with a lot of customers moving to cloud and finding benefits in cloud, the data warehouse also got shifted to cloud. That meant that there were a lot of benefits, obviously, the speed, the scalability, you could instantly scale in minutes. Dynamic scaling was introduced if you're a retailer and you want some additional throughput in the month of December, etc. Those are all great, benefits that you had. But there was a lot of vendor lock-in. So you could sign up with an AWS or an Azure, and you were just stuck to that place, and you couldn't really move out. The egress ingress charges were very high, and the CFOs were literally struggling to pay the bill for some of these technologies. So that was a sort of a limitation. So today what we have is a concept called Lakehouse, which is basically bringing in all the benefits of a traditional data warehouse and a traditional data lake into a single repository called Lakehouse. So it's sort of a marriage between a data warehouse and a data lake, so to speak. And the advantage here is you could run sort of use cases and workloads on one single platform as opposed to having a data lake and a data warehouse. A lot of banks that we speak to today, they have a data lake where the data lands initially, and then from the lake, the data is then consolidated and stored in a data warehouse, and some BI workloads are running on top. So the Lakehouse has a lot of benefits. So it's literally a sort of a marriage between the two technologies. So in data warehouse, we were typically storing structured data. And in data lake, we were storing unstructured data. And the use cases where data warehouse was used for BI, traditional, reporting from Power BI or Tableau or Cognos. And with data lake, it was sort of a dumping ground. Customers are collecting data from multiple sources. They just dump it into a data lake where it actually becomes a data swamp as opposed to a lake. And then from there, the data is pushed to warehouse. So there is obviously limitations in that approach. So with a data lakehouse, you're able to bring all the benefits of both these technologies into a common platform. For instance, you can store both the structured data and unstructured data into a common platform. And the data type itself has changed. It's not your traditional row column storage. It is stored in a very open format. And you also have the ability to scale from terabytes to petabytes in Lakehouse, which is traditionally not very well managed or done in a data warehouse environment. And in terms of the use cases, you can now look at all your use cases, such as your traditional BI and also more advanced analytics. And now we're talking about Gen AI, which predominantly works on unstructured data as well. So you now have a fit for purpose engine that allows you to bring all this data together and run your analytics workload. Now, this is quickly the Gartner's point of view from a lakehouse perspective. So Gartner is suggesting that a company should explore the lakehouse capabilities as a means of streamlining the data delivery and use it as sort of a converged infrastructure, data infrastructure, and to improve your governance as well. And we can use data lake for analytics exploration and AI development. Doesn't mean that you can technically you can get rid of your warehouse and your data lake, but every customer should start small. That's what we advocate. Start small, think about certain use cases that are candidates for a lake house. There are some use cases which are still, candidates for a data warehouse. So please continue to have them. So it's that combination of which workloads are meant for, or which technology is meant for which workload, plays a very important role in your decision-making process. And as you know, the technology platforms are so rapidly evolving by the day. It's sometimes hard to keep up with those technologies. But this is where companies like Alpharithm can come and help you streamline some of those thought process and create those technology areas for you. So now I'm going to hand over to my colleague Venkat, who is going to take us through the various options that are available from a lakehouse perspective, and do a little bit of deep dive in terms of both architecture and use cases. So yeah, I'll come back to you guys, connect with you again in a few minutes. Venkat, over to you.
Yeah. Hey, hi. So good afternoon. This is Venkat. I'm from Alpharithm. I'm an architect working with Alpharithm. And as Shri pointed out, we will have a look at the broad level, high level architecture of Lakehouse. And we'll also look at who are all the typical vendors who are playing in this field. And also we'll quickly give a snapshot of who are all the what are all the use cases that can be developed using the lakehouse concept. So just a moment. Yeah. So if you look at the structure of the architecture, you will see that it's got a sharing. Sorry, just a moment. Looks like my screen is not shared properly. Okay, sorry for that. So essentially, if you look at the architecture, it typically follows what you would have seen in a typical data lake or data warehouse architecture. You have this data sources onto the left-hand side. You have the ingestion layer. You have the storage there. That's where the difference comes in when it comes into a data lake or a lake house concept. Then you have the metadata layer, the API layer, and the consumption layer. Now, data sources, as we know, depending on the type of industry, whether it is retail, banking, or manufacturing, you'll have right from ERP to COT solutions to custom application that will be supplying the data. And you'll typically have the industrial layers, which consists of either open source ETL tools, or you will have tools like DataStage or Informatica, Talent, which will be picking up data from the sources and putting in, processing the data and putting it into storage layer. Now, in the storage layer is where a lot of different comes in from a lakehouse perspective, because lakehouse leverages a lot from the object storage capability and has given rise to different sort of use cases that can be run based on the storage type that gets stored in. And we then have the metadata layer, because increasingly organizations want to track the various entities or objects they are bringing in from multiple applications. That is essentially tables, the columns, the relationship between these entities, and what kind of schema that has been enforced, data versioning capabilities, keeping track of the schema evolution in terms of what are the structural changes happening. So all this is captured as part of the metadata layer. So there is an inbuilt catalog that comes along with the lakehouse, which catalogs all these things. Plus, it also catalogs the end-to-end journey of the what you call the movement of the data from the source to the storage layer, to through the API, or to the business intelligence layer to give end-to-end tracking. APIs are typically allowing us to expose the data in a self-service mode so that it can be consumed by different people at different endpoints. And then you also have the various consumption layers. So business intelligence layer can connect via the metadata layers and look at the data within this storage layer to create the kind of dashboard that needs to be presented to the management. Similarly, data science and machine learning can hook onto the metadata layer and access the various data that is lying within the storage layer or even at the source level, depending on the capabilities provided by the uh, tools or the platform to be able to do machine learning related aspects. In the next diagram, you'll see just a blow up of what I spoke about. So you have structured data, unstructured data coming along, moving in batch and streaming, processed by the ETL layer, put into the metadata, into the storage in the metadata layer. API is exposing it and then getting consumed across multiple layers. What I want to quickly talk about now is what are the various use cases that a lakehouse can be used for. So primarily, a lot of importance is given to lakehouse, wherein you want to bring in the lakehouse, the data lake and the data warehouse data together and perform analytics on top of it, perform AI on top of that layer. So data store as a data store for AI, which also supports vector database, is some of the common use cases we have seen where people are trying to implement a warehouse, the lakehouse. In data warehouse modernization, what is also happening is the lakehouse platforms comes with a very optimized query engine, which is one giving you data virtualization capability to connect to multiple types of data sources, and also gives you performances which are 10x, 100x of what you normally get out of any other query engine that is available currently. And we will cover some of these capabilities as part of the product platforms, which I will be talking about shortly. The other use cases that are happening around the lake houses, how to augment the legacy Hadoop platform or even replace the legacy platform, which means you have data lying on the legacy Hadoop platform. How can I make it easily consumable through SQL? Is one of the things which is very easily accessed across the data lakehouse. The other use cases, in case you're dealing with mainframe data, is how can you make the mainframe data accessible through the platform, the Lakehouse platform, because these platforms have uh, query engines that allow you to calculate the access the data that is there in the mainframe and bring it to a central platform. Then we have the capability of data virtualization, where data sitting not only in the lake house but sitting across various applications or data sources can also be brought in to create a sort of logical model from which the reporting or analytics can be done. um, One of the main advantages that the use cases which people look out for in a lake house is the cost optimization factor, where instead of using the traditional relational databases or data warehouses, columnar data warehouses where data is getting stored. They are preferring to store data in an object storage because there are um, object stores available on AWS, Microsoft, Azure, Google, as well as on-prem like MinIO and other platforms, also coming from some platforms coming from IBM, which allow you to create an object store or an on-prem or a cloud environment. And then leveraging Apache Iceberg, which is the core of the Lakehouse architecture, is to have the data stored in a tabular format, which summarizes over, which actually links the Parquet format uh, into a table on which asset transactions can be performed, thus giving you a capability of working uh, in an environment where you're able to do asset transactions and also able to run reporting workloads on top of it, as well as the analytics workload. So one of the distinguishing factors about the lakehouse is on the same data, that is object storage or a relational database, the combination of this, you can run a query engine or you can run an analytical engine on the same platform. You need not go for two different platforms to be able to run the different types of workloads. And then again, you have the semantic automation, which is augmentation and the visualization of data coming into the picture. Now we will go and talk about very quickly about four different platforms which support the lakehouse concept. So first, initially, I will get into Watson X. So in Watson X, we have three different pieces that comes in, which is the Watson data, the Watson governance, and the Watson.ai. All of these are lying on the Lakehouse platform, essentially where you have an object storage on which all the data is kept in. And using the multiple engines like an analytical engine or AI engine, you can run different workloads right from reporting to the analytical reporting. These platforms also allow you to do what is called as the AI ops and ML ops. So I'm taking you to the next visualization where you will see the various components that come as part of the Lakehouse infra, which is at the bottom, you will see the infrastructure, which is OpenShift, which is a container-based platform, IBM Cloud, AWS, Azure. Then you have the various storages, object storages like IBM Cloud, Amazon, Google, Azure coming into the picture. And then we have the metadata layer sitting on top of it. And the key components are the data format, which is Avro, Parquet. Now, Parquet and Iceberg are the ones which are very frequently used in the Lakehouse concept, where Apache Iceberg has actually revolutionized the way you would want to look at data from an analytical perspective as well as a reporting perspective. And you will see on the top the query engine, which is Presto, which is more related to querying from a BI perspective, that is querying responsible for providing the BI output. Spark and other engines which are used from an analytical workload processing, but they are housed out of the same infrastructure. So all you have to do is, based on the type of workload, you switch the engines and it works on the same set of data. That's the beauty of the lakehouse. You don't have to have two separate infrastructures, one for a data warehouse, one for a data lake. You can have both merged into one in a hybrid running out of the common platform. So you will see that this brings in a lot of advantages from an IBM perspective. We have multi-engine capability. 100% of the data is across accessible across the database and data lakes. Governance is definitely put into place because you're accessing data across multiple areas, so you definitely need relevance. Storage costs get reduced basically because object storage, we know, costs much lesser as compared to that of the other relational database stores that we typically look at. We will then go into the next platform, which is called Starburst. Now, again, Starburst is a platform that, if you look at it, it sits at the interface of the storage where the data is stored and where the BI reports are running on top of it, or the analytical reports or the analytical models are going to be run on top of it. So essentially, Starburst is built upon Treno, which is uh, a Presto-based modification that has been done where they are optimized it for massively parallel SQL. So it's a Starburst consists of a query engine that runs on top of any of the object storages like AWS, Google, Azure, as well as it supports additional ones like MinIO, which is also upcoming in the object storage realm. It also is able to connect to different other data warehouses like Snowflake, Oracle, Teradata, and enterprise databases from where you can pull the data. It gives you the context of data virtualization, so you can have virtual tables created. And through this, various reporting tools like Tableau, Power BI, ThoughtSpot can access the data, and the speeds at which these are deliverable are immensely faster as compared to the traditional BI SQL queries that are executed. You can use R, Jupyter Notebooks, or any other platform to access the data to run your AI and ML workloads on top of it. From a very brief overview, if you look at the structure of the Starbus, it consists of a coordinator and workers. It's like almost similar to your Hadoop platform where you have the master nodes and you have the worker nodes. So here you have coordinator, which is the equivalent of the master node, and you have workers, which are actually the one where the actual execution happens. And the distribution of the query happens across all these places wherever data is lying. Data is aggregated at the coordinator level and sent back to the client application that has requested. Similar to this, there is a platform called Dremio. Dremio platform is again something that enables us to work a bit more effectively in the Lakehouse pattern, basically because it has got some own constructs created. So it not only supports Apache Iceberg based um, tables, it also supports creation of what you call as reflections, a capability that allows you to create um, materialized views, which are also manifested as Apache Iceberg tables. So this also has a good query engine or a very super fast query engine that works on top of any of the object storages that is available. It creates the Apache Iceberg tables. It's got utilities that can create quick shot create the Apache Iceberg tables within the object storage and persist it. And then these can be used by various reporting or analytical tools for doing the various AIML operations on top of it. From a structural perspective, you will see that very similar structures, because they all are having a similar pattern of architecture. So they will have something called as a service load balancer, which essentially sits on top of the coordinators. The coordinator is just like a set of master nodes. This is where all the requests are coming from external applications, JDBC connectivity or Aeroflight, or from UI of Dremio or through REST APIs. And then it is pipelined through the coordinator and sent to the various different types of uh, engines, which are nothing but workers, which are classified as per the capability. So you'll see a metadata refresh queue, you'll see a reflection replace queue, and you'll see something called as the query queues. So all these are different set of nodes that have been logically categorized together to cater to a particular kind of workloads. And finally, they will pick up the data coming from the bottom layer, which is S3 storages like Azure, S3, or Google storages. So these are all infrastructure that are allowing us to access data from multiple places, which is through the Apache Iceberg capabilities of partitioning, and using the various combination of the execution nodes, you are able to get very fast responses to the query. And also you can connect to data sources which are outside of Apache, which are outside of the zone of the object storage, like source applications or other databases, and combine all this into a common query. Then last of the platform which I'm going to talk about now is Databricks, and I think most of you will be familiar with it. This also is built on a similar architecture, where at the bottom you have the storage layer where all the raw data is kept in. Then Databricks has got its own layer called as a Delta Lake layer, which actually manages the virtualization aspect of the query. Unity Catalog gives you the metadata and the governing layer. Data intelligence layer allows you to build the AI ML models and control the ML AI ops scenario through the pipeline flows. And we have the various implementations that comes in terms of Databricks AI, live tables, workflows, and SQL as different components part of it. So Databricks again has been doing leading work in this area of data warehousing, data lake, and now in the area of lake houses. And it is available cloud native on all the major platforms like Azure, Amazon, and Google. It incorporates all the capabilities of Lakehouse, Apache Iceberg into a common platform. It can be accessed by most of the reporting tools, standard reporting tools that are available in the market. On top of it, it also gives you the auto ML and ML flow tracking capabilities built into the platform. So pretty much comprehensive. It's very much comparable in terms of the capabilities you would have seen initially in Watson data. These two are essentially competitors in the overall end-to-end solutioning aspect from a fabric perspective, whereas the Dremio and the Starbucks figure out more in the aspect of Lakehouse and the query engine aspect, where they are able to give very good responses to the queries, analytical queries that we need to cater to in a typical environment. These are some of the figures figures or the products which we talked about, a quick summary of what are the various type of queries they are using and what are they. And there are a lot of vendors who are catching up, coming up with more and more packed capabilities in terms of query optimization and execution to be able to add speed to petabytes and terabytes of data. So if you look, we'll also have to look at what are the kind of benefits typically a lake house would give when you already have data warehouse and data lake in an organization. So essentially, the important thing that Lakehouse has added is the capability of asset compliance to what was considered as a static uh, storage of data. Now you have a capability that you have Apache table in which you can add data, you can modify data, you can delete data. So that's a different game changer that has come in with, and entire thing has happened because of the advent of Apache Iceberg, which itself has come from Netflix as an organization which has contributed to the open source. The Other thing is Lakehouse can also help us standardize on the data sets. I mean, you can still have schema on read, schema on write kind of capabilities. So it gives you all the capabilities, the sum total of capabilities between data warehouse and a data lake in terms of being able to access data. Um, Governance mechanism, definitely, it is not thrown away governance mechanism. It has made governance the integral part of the architecture so that everything can be cataloged and kept a tab of. And there are additional capabilities it gives you in terms of identifying personally identifiable information, which can be masked, encrypted, decrypted as part of the platform capabilities. We are not covered it in detail, but just giving an idea so that it can be kept in mind when you're talking from a data warehouse or a BI where reporting is involved and you don't want those specific data to be seen by people from a reporting perspective. Then open standardized storage formats are all welcome here. Most of the formats are Avro, ORC, Park, everything is supported here. Databases are supported here. All the BI tools are supported. Most of the BI tools are supported. All programming languages being used are supported here. So it gives you a massive capability of using any tool which you want in an environment and then choose the right engine for executing. That's all we need to do. The most important aspect that is bringing in the power to the lake house is the separation of the storage and the processing. Here, the storage being object storage. I mean, this began with the concept of object storage, where object storage allowed you to store data, and then Spark capabilities allow you to create the compute to be able to process the analytical workload. So now both of them have been moved into a common platform. The best thing that has happened in the lakehouse scenario is the bringing in or the marriage of the engines that typically were put onto different machines. So the BI workload used to run on different machines, and the analytical workload is to run on different machines. Now they all come on the same machine. All you have to do is make a choice and then run your workloads on top of it. Again, the advantage is because we are having data warehouse which contains structured data and data lake which contains unstructured data. You can bring both together, and because you have images, video, text, everything coming together in a lake house, you can now have all the AI/ML capabilities getting implemented on lake house with the uh, more flexibility in terms of analyzing the data. Streaming support for end-to-end streaming also adds in more capabilities, and most important now, between it gives a single repository for many of the applications, which also allows you to improve the operational efficiency and see how the quality of data can be improved from this single repository. Because most of the organizations initially started off with data as a single repository, then they created a data lake as a single repository and trying to pump data from a data lake to data warehouse. Now both of these have come together on a common platform where you have a single repository, which is sum total of all the granular information, raw information you have, and the process information that is kept in data warehouse. So all put together, you have Lakehouse as a very promising platform that allows an organizational to cater to multiple of its needs, right from structured standard reporting, senior management reporting, to ad hoc reporting, to targeted analytics, to exploration in terms of Gen AI, which is what most of the organization looking for. One single platform cater into all the needs. Now, this is where I take a pause because I'm handing it over to my colleague Arvind, who is now going to take us through some of the use cases he has configured using the AI and Gen AI capabilities. Arvind, over to you.
Thank you, Venkat. Venkat, if I could share screen and stop share.
You're on mute, Arvind.
Hello. Venkat, can you stop sharing? I'll start share my screen.
Or stop the share.
Yeah, sure.
Yeah, Arvind, you can share your screen and take it forward.
Sure, thank you.
Arvind, you're still on mute.
Arvind, you're still on mute. Hello, can you hear me?
Arvind, you are on mute. We are not able to hear you.
Hello, hello, hello.
Yeah.
Yeah. Okay. Hi guys. I'm Arvind. I'm working with Alpharithm, developing generative AI solutions for enterprise clients. So here we are presenting some of the carefully curated AI pilots that we have developed for enterprise use cases. So these solutions are available both on cloud as well as on-prem. So these are the AI leading AI technologies with which we have built the solutions. IBM Watson X AI, Microsoft Azure OpenAI, Amazon Bedrock, Google Clouds Vertex AI, and also we have used some open source models and local LLMs from popular repositories like Hugging Face. So these are the technologies that we use to build these solutions. We have also mentioned a lot of industry use cases for utilizing these AI solutions. So you can check this website out. The link will be shared across. And here we are looking at the 6 AI pilots that we have come up with. So the first solution is summarizing large documents. Say, for example, we have a large PDF document or a large, CSV document, a large SQL database. So, like it is manually very tiring to go through the entire document and summarize what is there in it. So instead, if we feed the AI with the large document, it breaks the large document into small chunks of information and it gives back. So this is one of the solutions that can be deployed. And then the second one is a chatbot for your own knowledge base. So Sri was mentioning about Chat GPT. How do we bring a technology like Chat GPT into our own enterprise data? So this is where this solution comes up. So we give a knowledge base to the AI, something like a website or a company's policy document or a company's financial. So you can give any knowledge base to the AI, and AI will use that knowledge base as its like the backend, and then whatever input that we want, like whatever chat that we want to make with the data, we can do it in the natural language. So the AI will understand what you are asking. It will go back to the knowledge base and it will match and fetch the right information and comes back with the answer in a natural language format, so that it becomes incredibly easy for you to chat with your own data. Third is converting a natural language to a query. So a lot of times we have problems in constructing large SQL queries to get data that we want. So where AI will come into the picture is when we talk to numbers like CSV files or so that time what will happen is when we enter a natural language query, the AI will convert it into the SQL query and it will perform and it will bring back the answers. So this is another solution that we have come up with. And then we are looking at unstructured data, something like video, audio, where there is no format or a structure to the data. So when we give the unstructured data, to the AI, it will break that data into a structured format and it will give back in the way that we want. So that is also an important solution that we've come up with. And then we are looking at analyzing sentiments. So there is a lot of news articles or a lot of text documents that has information about the company. We are feeding that data to the AI, and AI will tell you the sentiment. How positive is the document, how negative is the document. Say this will be very useful for CRM related queries or some toll free like customer care agents who are talking to the customer, and you just take the audio of that entire recording and then put it to the AI will summarize what is happening in that call, whether it is a positive call or a negative call, and what is the key action item that you are going to be taking away from it. And then the last one is identification of anomalies. That is, you have a perfect use case. That is, this is how my product should be. And then there is a real-time use case. And then the AI will match the perfect use case with the real-time use case, and then will identify if there is any abnormality, and then point out to the user that there is some abnormality with the real-time data, so that we can go and check. So I'm going to showcase these use cases to you. So here I have actually downloaded a PDF document about generative AI, and I'm uploading that to the summarizing tool. So you can see that. So this is the document. Like it has around 7 pages, and you can see that AI has summarized the entire document in a 5 to 6 bullet points. So this is the first use case. So second use case is so the same document we have bought it inside the chat functionality. So I'm just going to ask like what is generative AI. So you can see that in a matter of few seconds, it goes and it fetches, the information from this PDF as a backend, and it matches with my question and gives the answer. We can ask a even more complicated question, something like, this Japanese language is there. So we can ask like, is there uh, any mention? So you can see that the Japanese language Llama 2 is available in Tokyo region, and you can see that the information is accurate. So this way you can chat with the PDF like that. And then here is the, the chatting with the numbers I was telling. You can see that I have uploaded a CSV of around 1 lakh customer data. And here the columns and rows are not, related to the question I am asking. So there is no, so here you can see that the only the subscription date is there, and there is no information about customers. There is no column called as customer, only first name last name like that is there. So here I am asking a natural language question: how many customers subscribed in November 2020? So it goes and it looks at this data and it comes back around 3,400. It has gone and fetched data from this entire customer base, and it has come back with this answer. And then here we are looking at an unstructured data. So this is a YouTube video, like IBM Partner Plus Deep Dive YouTube video. So we are putting this YouTube video here, and the AI is actually creating a summary of the entire video. So here is this, the title, the summary of Partner Plus, what they have told in the interaction, and the summary from the entire video is here. And then the conclusion, like what do you want? So instead of watching the entire like 10-minute, 15-minute video, you have consumed the content in a matter of few seconds. And then this is the sentiment analyzer. So I have picked up a news article from Indian Express, and if we just give it, it gives the sentiment analysis. So the model is trained, what are the sentences that are having positive connotation, what are the sentences that are having negative connotations. It understands the text from the URL, and it gives back whether the sentiment about the article is positive or negative. So you can look at like if there is any news coming about your company, like you can have a social media listening, like if there is any negative or a positive word of mouth that is happening with this tool. So this is one thing. And here's the last tool, the anomaly detection. So what we are doing with the anomaly detection, I'm just presenting a use case. So like say for example, we have a food, like food item in front of us, and we have an ideal calorie that we have to consume. Like I have to consume only 500 calories, or I have to consume only 1000 calories. So the perfect condition here is it should be 500 calories, and I am uploading a picture of a milkshake here. So here the AI is understanding what is in the image first. The image contains 3 glasses of milkshake. The glass on the left is vanilla milkshake. In the right is chocolate. In the middle is strawberry. And then the vanilla milkshake is topped with whipped cream, pink, sprinkles. And it understands the what is there in the image actually. And then it tells the calorie count for each of these items. And then it says vanilla milkshake is having 550 calories, strawberry milkshake is having 450, chocolate is having 600. So it goes back to the anomaly and looks at the 500 is the perfect condition. But here only the chocolate milkshake is exceeding the condition by 100. So this is the anomaly detection. So here we can define anything, like for example, like the barcode should be pasted in the right side of the product or left side of the product. So you can just upload the image real time. It understands the perfect condition that is right side. Whichever product is left side, so it keeps giving that anomaly detection. So these are some of the generative AI use cases that we have built for enterprise purposes. You can check it in ai.alpharithm.com, and yeah, that's it from me.
Thank you. Thank you so much, Arvind. That was very thought-provoking in terms of what AI can do for enterprise customers. Thank you so much for that. I'm just going back to my slide deck. I think we were here. So just on the AI itself, on top of what Arvind said, what I wanted to highlight is we are sort of a vendor agnostic firm. We support and understand multiple large language models that has been introduced in the market. If you guys are familiar with the Hugging Face, it's like a GitHub for AI models. So we work with majority of the models that is getting published in that space. We work with Amazon Bedrock, we work with OpenAI, we work with the Azure version of the OpenAI, and IBM Watson X, and so on. So today you saw a sample of the art of the possible from an AI perspective in terms of what use cases are applicable. There are hundreds and thousands of use cases, but we just chose to pick up some of the 5 or 6 ones that are quite familiar, quite hot in terms of how do we quickly bring AI into the organization? What are the small wins that we can showcase to our management? Because every CEO is thinking about bringing AI into the organization. Some organizations don't even know where to start. So we can help you sort of have conversations around those small use cases and how do we quickly build them with your own data on-prem if that is what you want, because you don't want to expose your data to the outside world or put it on cloud. So we have solutions for that. Or if you're okay with cloud because your data is already sitting on cloud, then we can help you build those use cases on cloud itself. With whatever technology we think is right fit for your organization, right? Depending on the use case. So I just wanted to highlight that as an option that is available for you. And in terms of what we can offer, obviously we are a data and AI company. We've been doing this for the past 15 years now. So we come and look at your data landscape, understand where you are in your data maturity curve. We map that to, let's say, a CMM5 model, and then say, hey, you are actually in your journey from a data management, data governance, AI perspective, you are probably in 1 or 2, but what is that you need to do to get from 2 to 5, for instance. So we can help you with that. If you want that sort of structured thinking and approach, we can help you with that. We can also help you with, if you already identified certain use cases that needs to be built from a data management perspective, whether it's writing ETL or whether it's ingesting data into a warehouse, data lake, lakehouse, BI, AI, whatever that is, we can help you with that. Both development, implementation, and also support. If you're also struggling to put up a business case, whether it's AI business case or a data lake, lakehouse, data warehouse business case, to convince your management that, look, I have data challenges, I have data quality issues, I have master data management issues, because that is one of the other forte that we have. You want to build a single view of customer, product 360, whatever that might be. We can help you put a business case and create an ROI justification for your management so that you can, get funding to implement that within the organization. All this can be done via pilots, POCs, proof of value, proof of experience. Various options are available to you as a customer that we can come in and, talk to you about and help you. Please reach out to us in case you have some of these challenges and you need some help. Yeah, I think we are almost at the end of this webinar today. There is a little bit of time we have for any Q&A that you might have. I have seen there are already about 60, 70 questions. We've tried to answer some of them. There's a lot more questions. I think some of the questions requires sort of an in-depth discussion with each one of you, and we are very happy to pick it up as after the webinar in an offline mode. So please fire questions, and if you if you have more questions, we're happy to share the email IDs, and you can send it to us. Yeah, so I will now open the floor for any questions. We have a bit of time for some questions. Justin, are the audience allowed to ask questions, or is it only through the chat interface? Sorry,
Only through the Q&A session.
Okay. Okay, thanks, Justin. Okay, so I'll pick up some of the questions from here. I don't know if everyone has seen it. Most of the questions has been around the data lake house itself, and how I think most of you want to know how AI can help in the data management process, right? Now, data management as a as a framework has been around for a long time. It's very labor intensive. Today, if you know, data management is a broad topic. We are talking about a lot of things in data management, ETL databases, you know, data governance, managing the life cycle of data, archival backup, all that is data management. Now, how can AI help in enhancing data management is one of the questions I came across. I thought it was quite an interesting one, because AI, as we all know, is having an impact on every single activity within an organization. And today, Arvind explained some of the use cases where you're already sitting on structured data, unstructured data, and how do I, you know, play with it? How do I derive value from the data that I have? So for example, if you want to read a document, you know, 150-page document, it'll take ages to do that. Whereas with AI, you can ask it to summarize, and you can read the context of the document in 1 minute or 2 minutes, and then decide whether you want to further spend more time into it or not. But from a data management perspective, the areas where vendors are working on today, or how to automatically run ETL, write ETL pipeline. So we know that AI today is able to generate code automatically. You can ask it to write a Python code or an Angular script, right? So that is already happening now. Let's say you can go to ChatGPT and do it, but what we are saying is we can bring the same large language model that ChatGPT uses, which is OpenAI, and we can include that model on-prem, and then you can ask you know, let's say OpenAI or even IBM Watson X to write code for you, right? Generate a Python script to solve a particular problem. Now you can, so if you're running data pipelines using Python, Spark, whatever that might be, you can use that to generate code automatically. Some of the other vendors are actively introducing AI in the data management to generate ETL pipelines in the visual form as well. There are also data quality rules that are getting written today using AI. With Copilot today, you can ask Copilot to say, generate validation rules or data quality checks so that nobody has to think about. You typically go to a business and ask, "What I have this data set. What sort of validation do you want me, Mr. Business?" So sometimes business also don't know what they want. So you could ask AI to write those, and then it's just a matter of going to the business or your architect and validating what those are, and then building them, right? So data quality is a big area where AI is definitely going to play a big role as we move forward. Then some of the other questions I'm seeing here are around you know, the difference between data lakehouse and you know, data warehouse itself. Again, we have covered a little bit of that. I've managed to answer some of those questions. I think Venkat is still trying to answer them. There are some questions around data mesh. Now, data fabric and data mesh are two prominent frameworks that most enterprises are working on now. Data fabric is a sort of a centralized approach. Data mesh is a decentralized approach, right? So you bring all the data together in a data fabric, whereas in a data mesh, you keep them separate. You have dedicated domain-specific information that is sitting within a data product, as that is called, and then all the ETL and all the data, you know, central repository, single source of truth, and BI, AI, everything is working towards that data product. So that's the major architectural difference. A lot of benefits and reasons and use cases for each of these approaches. Happy to take it offline and discuss with anybody who might be interested in talking about that as well. One of the other things I've come across in the question list is the PII compliance requirement. We're all talking about the DPDP bill. It's going to have a major impact on how we collect data, store data, process data within the enterprise, because PII information is becoming very, very important. Identification, classification, recognizing the PII, and also consent is a very important topic with customers and enterprises these days. We have our own point of view on sort of technologies that will help address, DPDP bill. So if any of you are interested in that, please reach out to us and we'll be more than happy to help. Some of the other questions we will endeavor to get back to you the moment we have some time after the webinar. But thank you so much, guys, for joining in today. It's been a pleasure, meeting you all today and chatting with you. Happy to take this discussion forward in any form or shape. And you guys have a great Friday and a good weekend. Thank you.
I can answer.